This is grade 11 physics, the first unit, Introduction to Units and Measurements. By the end of this video, you will have a clear idea on why measurement is needed, what are the different types of units of measurements, CGS system unit of measurement, MK system unit of measurement, and SI unit of measurement. Then you will learn the fundamental and derived units. So to begin with, what is a measurement? Look at this picture. You have to measure the length of this pencil. To measure the length of the pencil, you need a ruler. And you are measuring the length of the pencil, which is an unknown physical quantity, with the help of a standard unit. On comparing the length of the pencil with the ruler, you get it as approximately 7.3 centimeter. So what is basically a measurement? It's comparing an unknown physical quantity with a known physical unit. Another example, look at this. You want to measure speed of a car. You are measuring the speed of a car in comparing its value with a speedometer, which gives you approximately 240 kilometers per hour. Now, another example, you want to measure the total mass of this, which is unknown to you, and you are comparing it with a standard unit, which is kilogram, and on comparing its mass with a balance, that gives you approximately 1 kilogram. Now, we move on to the next subunit. Why is measurement needed? See, there are 5 reasons. The first reason among them is it helps you to describe a physical quantity clearly and very precisely. Than saying the pencil is long, or the car is heavy, the car is moving fast, that is not very precise. In place of that, if you make a measurement, that will give you a clear idea of how much is the height of a person. 1.75 meter is more meaningful than saying he is tall. Another example, mass of a person is 80 kilogram, which is more precise and clear than saying he is heavy. Look at this speed of a car. It's fast. Doesn't make any sense. But if you say the speed of the car is 100 kilometers per hour, it gives you a clear, precise measurement. So what is the reason number 1? It helps you to describe any physical quantity very clearly and very precisely. Reason number 2, it allows comparison between different objects. Look at this picture. If you make a measurement with a balance, that gives you 2 kilogram. If you make the measurement of this with a balance, that gives you 1 kilogram, then you can compare. The first one has a mass double than the second one. And you can say the third one has almost half the mass of the second one. So what is the reason number 2? It allows a comparison between different objects. Now let's go for the third use. The reason number 3 is it is essential in physics. Why? We do experiments in physics and we do lot of laws in physics. So to verify the rules in physics, we have to make proper measurements. Look at this. You have done Ohm's law in grade 10, where you have to draw current versus voltage graph. And if the graph is a straight line, you know the device obeys Ohm's law. To plot the graph, you need data, you need the numbers. For that, you have to make measurements with a voltmeter and with an ammeter. So the third reason, why do we make measurements? It is a must to verify the rules in physics. Look at this. They are performing the investigation. For that, they have to measure the voltage with a voltmeter. They have to measure the current with an ammeter. And you have seen, they plotted a graph. So remember, the third reason, it is a must to verify the rules in physics. So we move on to the next reason. Reason number 4, it ensures uniformity and standardization all over the world. Look at this. Suppose you're measuring the mass of gold with a digital balance. You can see here it is 100.30. It is 100.123, that much precise. Anywhere in the world you take this piece of gold, it will show you the same thing. Why? Because the measurement is standardized all over the world. Another example for that, let's see, saying gold. Suppose you want to measure the diameter of a gold ring. It is very precise, it is very accurate. Why is it? Because the measurement ensures uniformity and standardization all over the world. And the last one, the fifth one, reason number 5, it is needed in daily life. It is needed in constructions, it is needed in medicine, it is needed in technology. Let's see, they are making constructions to measure the length of the room or height of the building, etc., etc. They have to make measurements. In medical purposes, heartbeat you have to measure, pressure you have to measure, and temperature you have to measure. And in technology, look at this, the speed of the car has to be measured, whether the car is moving within the speed limit permitted. So they have to use the equipment to measure the speed of the car. Why is measurement needed? Summary, I repeat again, it describes any physical quantity clearly and precisely. It helps us comparison between the sizes, the masses, lengths, etc. of different objects. It is essential in physics to verify the rules in physics. And the next one, it ensures uniformity and standardization all over the world. And the last one, which is not the least, which is applicable in our daily life. What is a physical quantity? You remember, we have measured the temperature, we have measured speed, we have measured the length, we have measured the mass. Let's see, we have to know about all these terms. Time is a physical quantity. Why is it a physical quantity? You can measure the time with the help of a stopwatch. Now, length is another physical quantity. Why? You can measure the length with a ruler. And the next one I'm saying speed, which can be measured with a speedometer. Next, mass, which can be measured with balance. Then comes electric current, which can be measured with an ammeter. The next is temperature, which can be measured with a thermometer. Next is weight of a person, which can be measured with a Newton meter. The last, pressure, which can be measured with a barometer. So what are these quantities? We call them physical quantity. Why do we call them physical quantity? Which means we can measure directly or indirectly. Can you give some examples for that? All these. Length of the room, mass of the person, velocity of the car, temperature of the body, area of the surface, volume of a cube, density of air, body pressure, blood pressure, etc., etc. Now, what is a non-physical quantity? And I need some examples. Simple. The opposite of this, which we cannot measure directly or indirectly. Love we cannot measure, hatred we cannot measure. So they are the examples of non-physical quantities. Now, we will do some questions on that. Look at this. Which of the following is not a physical quantity? You know, length is a physical quantity which can be measured with a ruler. Mass is a physical quantity measured with balance. Time can be measured with stopwatch. Air is not a physical quantity. Air is a material. Let's go for question number 2. Which of these is a physical quantity? Hatred is not a physical quantity. Like or dislike is not a physical quantity. So acceleration can be measured. So acceleration is a physical quantity. Moving on to the next. Curiosity leads to what? Obviously, curiosity leads to science. It leads to observation, but not only observation. It leads to experimentation, but not only experimentation. It is leading to science. All of them together. Why measurement is needed? Remember, we learned it before. The first one, it is correct, which is needed to describe any physical quantity clearly and quantitatively. True. It ensures uniformity and standardization. That is also true. It is needed to perform experiments and verify the rules in physics. True. It ensures accuracy and reliability. So all of them are true. So the answer is D. Next is assertion, reason types of questions. Look at the assertion given. The precise measurement of physical quantity is strictly needed to understand and verify the laws of physics in nature, which is true. Let's read the reason. Every physical measurement consists of a numerical value and a standard unit. That is also true. Now, let's see the choices. This says reason is false, wrong. This says assertion is false, wrong. Now we have to think between A and B. Let's see whether the real reason is the reason for the given assertion. No. Why? We need measurement. Why do we need measurement? Because to verify all the physical quantities, we have to make measurement. Is it given as the reason? No. So reason is not the correct explanation for the assertion. So the answer is B. Let's move on to the next one. The physical act of measurement is fundamentally the process of comparison. That is true. To quantify a physical phenomenon, we must compare the unknown quantity against a universally accepted standard reference of the same type. That is also true. Since both of them are true, this is wrong because it says A is false. This is also wrong. Now between A and B as before. Now do you think reason is the correct explanation for A? Yes. We make measurement for what purpose? To compare an unknown quantity against a standard unit. So A is the correct choice.